Okay, problem one, prepare a probability distribution for the experiment. Let x represent the random variable. So x is my random variable. And then p represents the probability. Probability distribution is going to have these two columns. X for your variable, what you're measuring, and p the probability of that outcome, that event rather. So the experiment is 4 coins are tossed, and we're recording the number of heads we get. If we toss 4 coins, each time we toss a coin, that's 2 outcomes. And doing it 4 times, 2 to the 4th, that should be 16 outcomes. So our sample space, I'm going to try to list this very systematically. So let's start. Let's do heads. Let's do 8 heads. Then 8 tails. Then let's do 4 heads, 4 tails, 4 heads, 4 tails. Then let's do 2, 2, 2, 2, 2, 2. So heads, heads, tails, tails. Heads, heads, tails, tails. This method will ensure that we get every single possible outcome. And then alternate heads, tails, heads, tails, heads, tails, heads, tails. And that should be a list of every possible outcome of heads and tails when you toss a coin or toss 4 coins. So let's count the number of heads here. I didn't leave myself much space, but let's say the number of heads. So there's 4 heads here. There's 3 heads here. 3 here. 2, 3, 2, 2, 1, 3, 2, 2, 1, 2, 1, 1, 0. So I just counted the number of heads. So those are all the possible number of heads we can have. We can have 0, we can have 1, we can have 2, 3, or 4. That's what we're measuring, the number of heads. These are the only possibilities. You can't have 5 heads if you toss 4 coins. Right? It's not possible. So now we're going to calculate these probabilities. The event where we get 0 heads, there's only 1 outcome out of the 16 where that occurs. So this probability is 1/16. Probability of 1 head, it's 1, 2, 3, 4 outcomes out of 16 have 1 head. Simplify that, divide by 4, it's 1/4. 2 heads, 1, 2, 3, 4, 5. 5 outcomes out of the 16 have 2 heads. 3 heads, 1, 2, 3, 4. 4 out of the 16. It's 1/4. And then all 4 heads, 1 outcome out of the 16. Now, if you add all these probabilities, they should actually add up to 1. 16 out of 16. So that's 5, 10, 14, 15. Oh, what happened? See, I missed one. 1, 2, 3, 4, 5. There's actually 6. See, don't be like me. Don't make that mistake, right? There's 6 outcomes that are 2 heads. 1, 2, 3, 4, 5, 6. So divide each of these by 2. That's 3/8. Now, see, if you make that mistake, the way that I caught that and the way that I found that was by adding these outcomes together and ensuring that they add to 1. So it's like I double-checked myself. So I counted here. I counted incorrectly. But then when I added these outcomes, now 5, 6 is 11, plus 4 is 15, plus 1 is 16. Now I can be more sure that I'm correct. So definitely double-check that when you work this kind of problem as well. So that's number 1. Here's number 2. 4 coins are coin. Wait a minute. Isn't that the same thing? Yeah, I guess they're the same. So 1 and 2. Wait a minute. Yeah, 1 and 2 look the same, don't they? Okay, so there you go.